Algebra 2, Concept 16B, Teacher Talk, Finding Zeros and Graphing Polynomial Functions. All right, let's hit the highlights of this concept. So the first thing is that knowing characteristics of polynomials will help us ultimately see what this function is doing and what the graph looks like. So let's look at these and state the degree and the leading coefficient and then describe the end behavior. So number 1, find the biggest exponent term for the degree. You are correct. The degree is 4, and we're concerned that it's even. Now pick out the leading coefficient. It is 6, positive 6, and that's what we're concerned about. So if we have a function of even degree, that means the end behavior will either be the same, up and up, or down and down at the ends of its curve. If the leading coefficient is positive, that means that the end behavior will go in the positive direction, so up and up. You can draw two up arrows, or you can say the end behavior is up and up. So on the left end of the curve it is heading upward, and on the right end of the curve is also heading upward. All right, number 2, in your mind, pick out the degree, biggest exponent term. You are correct, it is 9. That's odd. Leading coefficient is -5, and we're concerned that it's negative. So if you have an odd degree, that means the end behaviors will be opposite, either down and up or up and down. So look at your leading coefficient. If it's negative, it's like a negative linear slope. It falls. So your end behavior of the graph, it will be up on the left end and down on the right end of the curves. So let's put it all together. Let's start by setting this function equal to 0 and factoring. And so to factor, we're going to put it in standard form. Remember that factoring process. So start by factoring out a greatest common factor, and in this case it's x squared. Then look at what you have left. Notice you have a quadratic, and so you're looking for two numbers that will multiply by -6 and, to get -6 and combine to get -1. So -3 and 2. So that quadratic will factor as x minus 3 times x plus 2. Now, before we set each of these factors equal to 0, let's notice the power, because this determines the multiplicity. So our first term has an even multiplicity. That means the curve will touch at that 0 but not cross through the x-axis. It will bounce back. At our other 0 points, 3 and -2, since it has odd multiplicity, it will cross through the x-axis at that intercept. So we have x-intercepts at 0, +3, and -2. So let's set our graph up. There we go. Label your scale. Now, notice I have plotted those 3 points at -2, 0, and +3. Before I draw my curve, I want to talk about the end behavior. So the degree is 4. It's even. Leading coefficient is +1. So I will have end behavior and that is up on the left and up on the right. So I start just to the left of my furthest 0, so just past -2, and I'm going to draw my curve down through that point, and then I'm going to turn back towards my 0, touch and bounce back, and then draw a curve and go back up through my third x-intercept. So in this case, I have like a W-shaped graph. You can see at those 3 x-intercepts how the curve is crossing through at -2 and 3 because it has an odd multiplicity, and bouncing back into that lower quadrant at 0. Okay, let's do the same process. Let's set this equal to 0. Factor out a 3x in this case. And then let's just keep factoring. So we've got a difference of squares, x plus 2 times x minus 2. Now notice the power of each of these factors. It's a power of 1, which is odd multiplicity. So the curve is going to cross through the x-axis at each of these zeros. So x will equal 0, -2, and +2. So let's draw our xy axis and label it. and plot those points at -2, 0, and 2. The degree is 3, which is odd, and our leading coefficient is +3, so our end behavior will be opposite, and since it's positive, it's like a positive slope, down on the left, up on the right. So you're going to start your curve just a little left of the 0 at -2. You're going to go up through that point, turn back, go through 0, turn back, and go through +2. So see how we cross, cross, and cross. And in between each of those x-intercepts, we just do a smooth curve, turn back through, and you curve in the middle as much as you can. And it does not matter how high you make those little humps in the middle, because we're just doing a sketch of this graph. Anyway, all right, that finishes the highlights of concept 16B, factoring and graphing polynomial functions.